Modern physics is currently navigating a systemic crisis rooted in the concept of ex nihilo construction, the assumption that physical systems emerge from an absolute void. This paradigm relies on arbitrary axioms to pull structure from nothingness. The theory of infinity proposes a shift to creation ex totalitate, where reality is carved and folded from an active absolute totality. Standard frameworks like Zermelo-Fraenkel set theory often posit initial structures without defining the geometric necessities that permit them. While these models offer localized utility, their reliance on ungrounded axioms makes them vulnerable to boundary failures when they are extrapolated to extreme cosmological scales. Under this new paradigm, infinity is an active ontological primitive encompassing all material potential and formal structure. This totality, often referred to as the infinite plenum, serves as the raw substrate from which every bounded, coherent world is extracted. This process of extraction uses a fundamental symmetry operator to define the golden set, the localized physical limit of our reality. In this framework, the cosmos is a specific, stable context sealed against a background of infinite potentiality. Classical models, from Kaluza-Klein to string theory, generally assume that higher mathematical dimensions require an expansion of space or an invisible microscopic curl. This assumes that adding degrees of freedom inevitably adds volume to the universe. The law of topological compression suggests the opposite. In a topologically bounded system, higher dimensions crush space inward. These dimensions serve as the dense inner structural geometry of matter, packing physical volume into restricted probability fields. When auditing a manifold reaching the shadow plane, it encounters Nash-Moser topological friction. To survive without shredding underlying functions, the manifold undergoes a modality shift. It sheds its asymmetrical curvature and crystallizes into the Fibonacci squircle, providing geometric ballast to maintain structural stability. This creates a fundamental question regarding scale. If the quantum core of our universe is a dense, high-friction environment of compressed geometry, we must explain how the macroscopic world we observe achieves its smooth, stable appearance. The theory of infinity identifies that fundamental quantum fields operate at high-frequency frequencies governed by the Fibonacci sequence. These integers provide the absolute scaffolding for the continuous manifolds of our universe. We can model this by overlapping two dense dimensional wave states. In this system, state 1 is governed by a mass constant of 34, while state 2 is governed by 55. Overlapping them creates a chaotic visual mesh. This interaction is governed by Cassini's identity. Adjacent Fibonacci numbers are strictly coprime, sharing no common divisors. Because these massive integers cannot be simplified, their rings cannot naturally align. In most configurations, this coprime relationship results in a lack of periodic alignment, creating persistent high-frequency tension across the manifold. For a stable macroscopic environment to emerge, the system requires a specific geometric mechanism to resolve this clash. This resolution occurs only at specific nodes, where the two wave states hit perfect integer multiples of a foundational unit plane. At these rare coordinates, the spatial requirements of both Fibonacci frequencies are satisfied simultaneously. When overlapping, their massive topological friction is neutralized. The high-frequency waves physically cancel out, leaving a low-frequency macrogeometry of simple intersection points. This is baryonic crystallization. Stable physical matter forms exclusively at these nodes, creating the Moiré lattice, a standing wave interference pattern. This proves that the macroscopic world is an emergent phenomenon. What observers perceive as a solid, continuous baseline is a geometric result of underlying quantum interference, bridging the high-frequency microuniverse and the low-friction macrouniverse. Maintaining this crystallized state requires a persistent force to prevent the system from dissolving back into the infinite totality. This necessitates a structural mechanism of cohesion. Within this framework, Grade is defined as the universal operator of structural cohesion, or syncretic gravity. Its role is to actively maintain the boundaries of the golden set, preventing the localized context of our universe from returning to a state of unstructured potential. Johannes Kepler's laws of planetary motion serve as a macroscopic manifestation of this crystallization. A central mass, like the Sun, acts as an ontological knot, a focal singularity that breaks the uniformity of space and provides the necessary asymmetry for a stable elliptical orbit. Planetary architectures utilize Fibonacci-derived ratios to space their orbits. These deeply irrational ratios smear gravitational influence across the system, preventing destructive mean motion resonance that would otherwise eject bodies and collapse the system's structural integrity. A solar system is a large-scale manifestation of the same Moiré logic found at the quantum level. It uses specific mathematical spacing to maintain a state of structural immunity against chaotic gravitational perturbations. Evidence of these discrete algebraic boundaries is also visible on individual planetary bodies. When these mathematical recurrences are embedded into continuous manifolds, they create visible standing waves. The Saturnian Hex-Pole is a primary example. While classical models attribute this to transient fluid convection, this 14,500-kilometer hexagon is actually a planetary standing wave. It occurs where the supersonic jet stream reaches a topological boundary, triggering a modality shift. As the continuous flow encounters Nash-Moser friction, the system applies the law of topological mass exchange. This transfigures the discrete integers of the underlying frequency into a geometric ballast, supporting the hexagonal shape from within the chaotic fluid dynamics of the atmosphere. From subatomic interference to the geometry of gas giants, the universe utilizes these rigid bounding boxes and topological compressions to forge a persistent reality. The stable world we observe is the result of these locked Fibonacci fields. We exist within a crystalline standing wave interference pattern. The theory of infinity demonstrates that our reality is not an accident of inflation, but a result of topological invariants, sustained by the precise geometry of the infinite totality.